So that this is this thing. R times E. Okay? This is complex number. Now for linear space you must have an operation such as plus from E times E to E that maps this order pair to E plus y. And in scalar
مفتوح كيف
multiplication.
هذه ثابتة؟ هو هذا مفتوح أصلا.
For example,
خليه
دكتور don't
شوف تشيك بس الصورة عبودي. لا
I
تمام.
send this for you. You have this file, okay?
أوكي عبد الرحمن شوفه أوكي. شوف الصورة ولك شوفها يا خلاص.
تمام
أوكي.
كان دكتور
يعني ايش قد تريد 10 ساعات يجي على 10 512.
اوكي.
We have this trivial example. Complex number itself is a linear space by the ordinary addition and multiplication. What is the ordinary addition and multiplication? Let me add.
ايش تكتب يا رجل؟
لا أنا نصور طعم
شو الحق بها العاب احسن
لا
أبي
بس اريدك تسأل سؤال قول له السلام ما يقدر يجي ويريد يعني دور ثاني اكو ولا شو؟
ورا المحاضرة
ورا المحاضرة.
أنت عادي زارين
إيه، خابرنا.
يا
خابرك وخابر علي وخابرني
هي خبر
ودز لي شو اسمه الإجازة
What
مالته.
is the operation plus?
قلت تامرني امر
Operation plus, okay?
اوكي
For example, if you have alpha 1 plus I beta 1 and then complex numbers. What is this? Plus alpha 2 plus I
beta 2.
beta 2. You know that this is equal to alpha 1
زائد
plus
alpha
alpha 2
2
plus
بيتا 2.
I B
beta 1 plus beta 2.
تمام.
yes
It is trivial that this is a real numbers and this is
I-
real
I-
numbers,
Tamam.
so that this is the complex number, okay?
تمام
And what is scalar multiplication? You can write this C times C to C alpha 1 plus I beta 1 multiplied by
ألفا
alpha
2
2 plus
زائد
I
I B
beta 2
بيتا 2.
equal to alpha 1
alpha
alpha 2
2
minus
يساوي لنا
beta 1
بيتا 1 زائد
beta 2
تمام.
plus I alpha 1 beta 2 plus
Alpha
alpha
2
2
beta 1.
beta 1
This is a real number again.
complex.
And this is the real number, so that this is the complex number. Okay. So we have these two operations from this complex numbers, and after this we define the definition of norm. Okay? Let E be a linear space. A norm on E is a map such as this. This is the function. From E to E, such that we have these three properties. The norm of X must be greater or equal 0 for any X in E. And also the norm of X equal to 0 if and only if
X uses
X equal to 0. 2. The norm of alpha X equal to absolute value of alpha multiplied by the norm of x. Okay?
تمام.
Please note that what is alpha x? Alpha belongs to C, x belongs to E. So that alpha x is an element of E, because we say that we have this operation, okay? Alpha x is an element of E. We need this operation because we will talk about alpha x, so that E must be a linear space, okay?
Yes.
And this is the absolute value of alpha. This is the absolute value of any
زين هذا تعريف.
complex number, okay?
معلومة.
But this is a norm of x. This is a norm of any element of E. And finally, this is triangle inequality.
زين.
Triangle inequality is very, very important in norm space. And also we need x plus y. What is x plus y? X plus y is an element of E again, okay?
عنصر ثاني.
So if you want a norm, at first you must have a linear space. X plus y must be belong to E. Alpha x must be belong to E. Then you must have these three properties, okay?
Yes.
And notation'ımız da indi. Ben derste şuna cevap veriyorum. Sürekli bu konuşmuyor. Dear students, this is coffee and tea.
Thank you.
Good. Okay?
Okay.
If this function, this is a function, this is a notation. You may consider this, for example, h. Okay? It is very important. This is a notation. This is a symbol. This is a symbol. Okay? This is a symbol
Symbol. رمز.
or notation. You may consider a known function is a function h, for example, from E to R, okay? If we consider h instead of this notation, you must say for any x in E, h of x must be greater or equal 0. This is instead of this, okay? This is h of x. This is a symbol of a function, okay? For this you must write h of x equal to 0 if and only if x equal to 0, okay?
Yes.
And for any alpha in complex numbers and for any x in E, we must have h of alpha x equal to the absolute value of h multiplied by h of x. This is instead of this property, okay?
Two.
Two.
Number two.
And for another, for any x and y in
This
E,
is 3.
3, yes.
Yes.
H of x plus y is less than or equal h of x plus
Plus H.
h of y, okay?
نعم نعم.
Now we denoted this function by this, so that we have these properties. This is a function. This is a very important. You must know that this is a function, okay? Okay, we see that complex numbers is a linear space. But do you know a norm function on complex numbers? We have norm function on complex number by this function rules for any alpha plus I beta in complex numbers. This norm equal to alpha 2 plus beta 2. You know that this is a real number, okay? And this, you must write this by these notations or this notation, okay? Okay? Let me check these three properties. Property 1, for example. Two and three. For property 1, we see that it is very trivial that for any, you can write this as an element such as z, okay, or simply by z. Z equal to this. For any z in complex numbers, it is very trivial that this is a non-negative real number, okay? This is a non-negative real number. And also, it is very trivial that if
and all if z is
z equal to alpha plus I beta equal to 0, we see that alpha must be equal to 0 and
beta
beta must be equal to 0. So that the absolute value of z or this radical
Alpha 2
equal to 0 if alpha and beta equal to 0. Conversely, if this equal to 0, we conclude that this radical equal to 0. And this shows that alpha must be equal to 0 and beta must be equal to 0. So that z must be equal to 0, okay? Z must be equal to 0. So we have this property that the norm of x or z equal to 0 if and only if x equal to 0, okay? For this norm and for any alpha in z or in complex numbers and z in complex numbers, it is very trivial that alpha z equal to this. It is very easy.
norm z.
No, we denoted by this, okay?
Yes.
We denoted by this. And also triangle inequality for any
X
z1 and z2, for example. In complex numbers, we have
triangle.
triangle inequality.
Right.
Is it less than or equal?
يساوي زي مطلق
You
6
can check these two properties easily, okay?
تمام تمام
So that we can say that so
alpha
the complex numbers with these function norms is a normed space. Okay?
Yes.
Normed space. You must know this definition and you must know these examples.
Yes, exactly.
But in the following of these definitions, we see another definition, okay? We have two definitions. If we have these three properties, E with this function is a normed space, okay? But we have this definition. This normed space is a Banach space if every Cauchy sequence converges. But what is the Cauchy sequence? The definition of Cauchy sequence. I write for you the definition of Cauchy sequence.
This is Cauchy sequence.
Yes, if E and this function norm is a normed space and Xn be a sequence in E, okay?
In E.
In all
Yes.
normed space. Xn is called Cauchy sequence whenever we have this property for any epsilon.
نتيجة الاسم لازم convergent.
No, this is normed space, not massive space.
Sequence, Cauchy sequence, convergent.
No. This is not convergent. This is only Cauchy sequence. For any epsilon, there exists n. N is a natural number, okay? Such that if m and n be greater or equal n, this norm be less than epsilon. Please note that xn minus xm is an element of E, so that this norm is defined, okay? This must be less than epsilon.
السلام ورحمة الله.
Welcome. And we say that xn converges to x. Converge, okay? If we have an element whenever xn converges to x, if for any epsilon there exists a natural numbers such that if n be greater or equal n, then this norm be less than epsilon, okay? In Cauchy sequence, we have xn minus xm. In convergence to x, xn minus x must be less than epsilon. It is very trivial. Please note that these real numbers can be smaller and smaller, okay? The distance of xn and x can be smaller and smaller, asghar and asghar, okay? Whenever this n be bigger and bigger, if we consider n sufficiently large, then this norm is sufficiently small. Salam. Welcome, Murtaza. Murtaza.
Güzel bir şey abi. Memnun.
Okay. This is the definition of Cauchy sequence. This is definition of convergence sequence. It is clear that if xn is a convergence sequence, then it is a Cauchy sequence. It is a very easy practice, okay? Any convergence sequence is Cauchy sequence. But the converge is not whole in general, okay? Cauchy sequence is not necessarily converge sequence. Now we see that this definition. If every Cauchy sequence is a convergence sequence, we say that this norm space is complete or Banach space, okay? We say that this norm space is complete or Banach space. we can write for you that any note that any Cauchy sequence is convergence sequence. Sorry, any convergence sequence is a Cauchy sequence. We don't have this in general. Is a Cauchy sequence. And its proof is very easy because if the limit of xn equal to x, for example, okay, for our definition for any epsilon, we have a natural numbers such that if mon be greater or equal n, then this is the convergence sequence. If n be greater or equal n, then xn minus x be less than epsilon. Okay?
نشوف لك هذا شوية مثل
No, it is very trivial that if you consider m and n be greater or equal, and we can consider this epsilon divided by 2, okay? If m and n be greater or equal n, what is this? xn minus xm. We can write this equal to xn minus x plus x minus xn. Okay? These two are the same because this equal to 0, okay?
واضح.
Now you can use triangle inequality. This is less than xn minus x plus x minus xm. And you know that all of this is less than epsilon divided by 2. Okay? So that this is equal to epsilon. So that if m and n be greater or equal n, this norm is less than epsilon. So that this sequence is a Cauchy sequence. Okay?
Okay.
So that any convergence sequence is a
Convergent.
Cauchy sequence, but not vice versa. Any convergence sequence is a Cauchy sequence. So xn is a Cauchy sequence. No? In the definition of Banach space, we must have this property. Every Cauchy sequence must be convergence. Okay? So that in Banach spaces, Cauchy sequence equal to convergence sequence. In Banach spaces. Okay? Cauchy sequence equal to convergence. No, the title of this chapter is Banach algebra, okay? We see the definition of Banach space. This is the Banach space, not Banach algebra. If we have another operation, we have Banach algebra. Let A be an algebra norm on A. This is a norm, but algebra norm. Such that we have this property, then we say that this algebra is a Banach algebra. The norm algebra A with this norm is a Banach algebra if and only if this is complete norm. So that we have two definitions. You know the definition of algebra. We must have a class operation, scalar multiplication. Maybe I write for you. If A is an algebra,
This is example.
no, this is definition of algebra. We must have three operations: plus, scalar multiplication, and multiplication. Okay. And if we have an identity element, we have this algebra is unital. Multiplication of A with E equal to E multiplication by A equal to A. For A, this is identity element, okay? And in the class we prove for you that these operations are continuous. These operations are continuous. For example, the operation of multiplication. Because if we have a sequence in A times A that converges to X and Y, then we see that we consider this operation by H, okay? H of xn and yn minus h of x and y equal to xn yn by this function rules minus xy. I added this. This is equal to 0 again, okay? This is equal to 0. And we have this equal to this. And now we can use triangle inequality. Triangle inequality. And this is less than this. For what? For this property. For this property, okay? The norm of AB is less than or equal the norm of A, the norm of B. Please note that. This is, for example, A for you. This is B, okay? So that the norm of AB must be less than the norm of A, the norm of B. And also for this. And also for this. So this less than this and this less than this. But these two tend to 0. We know that. These two must be 10 to 0. So that all of this must be 10 to 0. Or converge to 0. Okay? Converge to 0. So that this, the limit of this subtraction converge to 0, so that the limit of, I write this in this. The limit of h of x and yn equal to h of x and y. And also other operations are continuous. The operation of plus, multiplication, scalar multiplication, all of these are continuous, okay? And this is another example. This is the notation again, okay? CS, the set of all functions such as f from S to complex numbers. What is S? S is a set, مجموعة.
هاي صعبة علينا ما بدنا نفتهم هسه شنو معنى يعني هاي كومبلكس فوقها اس شنو اس؟
Yes, this is the notation. This is the ramp. This is the symbol, okay?
Symbol?
This is the symbol. This is the definition of this, okay? The set of all function. You say function in Arabic
دالة.
دالة, okay?
دال يعني بهالطريقة شكلها
مجموعة of
رمز هو.
ايه رمز اس فوق
Okay.
اس نعم
the set of all functions from S to complex numbers. For this, we want three operations plus scalar multiplication and multiplication, okay? We define these three operations for any f and g in this set. What is f plus g? F plus g is a function such that for any x in S equal to f of x plus g of x. Please note that we say that CS C, for example, complex numbers is equal to the set of all functions
اس
from
اس
S to C.
yes
So if we consider F and G in this set, F and G are functions from S to C. Now what is F plus G? We want F plus G be a function from S to C, okay? So we define for any, for example, X in S, okay? We define f plus g of x equal to f of x, and it is well defined Murtaza, because we know that f of x is a complex number, g of x is a complex number, so that we can define f plus g, f of x plus g of x. These two are two complex number. We see the definition of additioning two complex number, okay? For example, this is f of x, this is g of x, and this is f of x plus g of x, okay?
Yes.
Because we this operation defined in complex numbers, so that f plus g is a function from S to C, okay? And this shows that f plus g is an element of CS. CS is the set of all functions, okay, from S to C. And also for any x in S, we can define alpha f of x equal to alpha of f of x. Please note that this alpha is a complex number, okay?
Yes.
Alpha f defined by these function rules. It is very trivial that this is the complex number again, okay? Because this is a complex number and f of x is a complex number. So that alpha f is an element of CS, and also we define fg for any x in S. Fg defined on x equal to f of x multiplied by g of x, and this is the complex number, so that fg is a function from s to g. Please note that we define multiplication in complex number, okay? And also addition. So in this example, we have these three operations. These three operations. It is very trivial that CS with these two are a linear space, and with these three operation is an algebra, okay? Is an algebra. And also this algebra have an identity. If we consider the constant function 1, this is constant function, okay? 1. Every element tend to 1. This is very trivial that this is an identity. Because if, for example, we consider g equal to 1, this is equal to 1, okay? F of x multiplied by 1 equal to f of x. 1, 1. 1 is identity element in real numbers, okay? And complex number. And this is another example. L infinity of s equal to the set of all f in CS. What is CS? The set of all function from S to C. Complex number such that f is bounded, or the set of all f function from S to C such that there exists an m such that for any x in S, the absolute value of f of x is less than or equal 1. Less than or equal m. This is the definition of bounded, okay? مغير, okay? Or the set of all f from S to C such that there exists an m such that for any x we have this property. This is the set of L infinity.
هذا شوف يعني كل تطبيقات اف جي كذا.
And this is very trivial that if we consider these three operations, okay? Because we see that L infinity is a subset of CS, okay? It's very trivial that L infinity is a subset of CS. The set of all bounded element of this is L infinity. So that we have these three operations in L infinity. These three operations, okay? It is very trivial that if, for example, f and g are bounded, f plus g is also bounded. It is noted if f and g belong to L infinity of S, then f plus g is in L infinity of S. It is very trivial because if f and g belong to L infinity of S, then there exists two non-negative real numbers such that for any element in S, for example, f of x is less than m1 and g of x is less than m2. Now we see that for any x in S, f plus g of x by our definition equal to f of x plus
G of X.
g of x, and this is by triangle inequality less than or equal f of x plus g of x, okay? and this is less than or equal m1 plus m2, so that this function is bounded, so that f plus g is an element of L infinity of S. Okay, so you prove this simply. You prove this property. Okay, if f and g belong to L infinity, f plus g. Similarly, you can prove this is the consequence. If f and g belong to L infinity of S, then fg is bounded, okay, and also if f belong to L infinity of S and alpha belong to complex numbers, alpha S is in L infinity of S. Okay?
Yes.
So that in L infinity we have these operations, and L infinity by this operation is algebra and norm and vector space or linear space. No, we want a norm function, okay? We want a norm function in this linear space. Norm function. We define a norm function. A norm function from L infinity to real numbers. Okay? We denote it by norm of S. We can denote this by this notation or this notation, okay? In your book, denoted by this notation, okay? In your book. And define the norm of f equal to this supremum for any f in L infinity. Norm S of f equal to the supremum of f of x
Victor, please.
such that
This
x
is
belongs
definition.
to S.
Definition.
This is definition of the
Sorry.
norm
Oh,
norm function. Okay.
yes.
What is this, Murtaza? You know that if f belongs to L infinity of S, then f is a function from S to C, okay?
Yes.
So that for any x in S, f of x is a complex number, okay? F of x. And so that for any x in S, absolute value of f of x is a real number, okay? We define the absolute value of any complex number equal to this. This is a real number, okay? Okay? So that all of these are real numbers. All of these are real numbers. And this supremum is an element of real numbers because f is bounded, okay?
Large.
Because all of this f of x is less than m. Please note that. This is the definition of L infinity. We write in this. F belongs to L infinity, f that exists one m such that for any x, f of x is less than or equal m. Okay? So that all of this element is less than or equal m. This shows that
دكتور قال بلاش يمدرب يمدرب كي ايش ياسين
Okay. Okay? For what this supremum is not equal infinity? My question is all of these are real numbers, but it is maybe this supremum equal to infinity. But if f equal to L infinity, this supremum is finite, is not infinity. Okay? Let me write this for you. If f belongs to L infinity, we know that there exists m such that for any x in S, f of x is less than m, okay? So, this norm or this supremum is less than or equal m, because all of this is less than m, okay?
Bound.
Okay? F is bounded. So that this supremum is not equal infinity. This is a real number, okay?
Yes.
This is a real number. So I say this is a norm function from this to R. To R. Any norm of f is a real number. Now you can simply check that this is the function norm. Okay? This is a function norm. For example, for any f in L infinity, it is very trivial that this is non-negative. Okay? What is the property of norm? Okay? This must be non-negative, and also the norm of x equal to 0 if and only if this equal to 0, we see that this supremum must be equal to 0. The supremum of f of x such that x belongs to S. Okay? Because this is the norm of f. But this equal to 0 if and only if for any x in S, this f of x equal to this. Is it true or not? If this supremum equal to, sorry, this must be equal to 0, okay? Equal to 0. This equal to 0 if and only if all of this equal to 0.
0, yes.
Because if one of this is non-zero, this supremum is non-zero. Okay? If one of this be non-zero, this supremum is
Non-zero.
non-zero, supremum. Okay? And this holds if and only if for any x in S, f of x equal to 0, and this is holds if and only if f equal to 0. For any x, f is equal to 0, so that f is constant function 0, okay? So you have this property true. The norm of f equal to 0 if and only if f equal to 0. And also other two properties holds. For example, if f belongs to L infinity of S and alpha belong to complex numbers, it is very trivial that summary 2 is not property 2, okay? This property. For this example, is equal to, we must prove this, okay? And this is very trivial because if we consider this is equal to the supremum of absolute value of alpha f of x, okay? Whatever, because we have alpha f instead of f.
Yes.
Such that x belongs to S. And this is equal to the supremum of alpha f of x. This is the definition of alpha f of x, okay? Such that x belongs to S. And this is equal to the supremum of absolute value of alpha f of x such that x belongs to S. And we can exit this fixed number alpha from this supremum. So that this is the absolute value alpha supremum of
Absolute value of
absolute value f of x such that x belongs to S. But what is this? It is equal to what is this? What is the supremum?
Supremum.
This is the norm of S. Because we define this, okay?
Yes.
This is our definition.
Yes.
So we have this equality, and also for the third we see that for any f and g in an infinity of S, we have f plus g is less than or equal this norm plus
G norm.
this norm.
Yes.
And the definition applied to prove this inequality, it is equal to the supremum of absolute value of f plus g of x, okay? Such that x belongs to S, and this is equal to the supremum of f of x plus 0. This is the definition of this plus operation, okay? Such that x belongs to S, and this is less than or equal by triangle inequality in complex numbers. F of x plus, because we know that these two are complex numbers. We have triangle inequality in complex numbers. Such that x belongs to S. Yes, yes, yes. Yes, yes, yes. And this is less than or equal to the supremum of the first x belongs to S
Supplement.
plus supremum. And the first is the norm of f, the second is the norm of
G.
Yes.
so that we have another example, L infinity. But why this norm function? Okay. Okay, this is the definition, the proof of these properties, okay? The norm of this is non-negative equal to 0 if and only if f equal to 0 and these properties and triangle inequality, okay? I write this for you that you learn study this book and study this booklet, okay? You must learn line by line, okay? This is an algebra norm also, because we have, this is the proof of algebra norm, okay? For any f and g in L infinity we have this. What is this? This is this property, okay? We must have this property for algebra. And we have this and we prove this in your classes.
الجبر نعم.
Yes. The S norm of Fg equal to the supremum. This is less than or equal the supremum of f of s multiplied by the norm of s. I write because the absolute value of g of s is less than for what? Because this is the supremum of this object, okay?
Okay, good.
This is the supremum, so that this must be greater or equal all of this, okay?
Okay.
So instead of g of s, we put the norm of g. The norm of g is greater, okay?
Okay.
So that this is greater, another one.
Okay.
And this is the fixed number, Murtaza. This is the fixed number. So we can go outside of this supremum, okay? This is the fixed number. The norm of g is a fixed number, not dependent on s, okay? This is the fixed number. So that this supremum equal to this multiplied by this supremum, and this supremum equal to the norm of s. Okay? So this s norm is less than or equal the norm of g multiplied by the norm of a. And we have this property also. Another example is in topological space. We need the definition of topological space. In this definition, in your harmonic analysis course, we define the topology and topological space.
We know that this definition.
Yes, this is definition in your harmonic analysis course, okay?
Oh,
Harmonic analysis course.
this definition. Another this definition.
Yes, yes. This is the definition of topology.
Topology have definition in harmonic, one definition, and in
Yes, but in operator you must know this.
who's the must for definition?
Yes. In operator theory you must know this. But in harmonic analysis, you see the definition in your courses, okay?
Okay, no problem.
هذا شيء جناب دكتور إن زنبول شي بشيء يعني شيء
T.
In yani var
Topology.
talk demiş, talk.
ها
Talk. Greek symbol. Yani what Yunani. Alfa, beta, gamma. This is
مثل مثل الفا يعني
مثل alpha. This called talk.
هذا بسيط
Talk.
كلش بسيط.
موجود هذا التعريف.
You can write any symbol. You can write 8 for example, okay?
تي مثلا
T,
شيء
هذا يقول
8,
لك
okay?
بالتعريف الثاني. قلت له هذاك حافظينه يقول لا.
You can write 8.
يعني هذا ما غيره ما
Any
غيره.
any symbol. Any symbol.
ها؟ قصدي هو تعريف التوبولوجي انتم ماخذين الكورس السابق هذا. هسه ما يفيدكم هذا. قلت له مشى عليك الله شو قال لا ابدا لا تسولف.
Please note that let x be a set. X be a set, okay? Tau be a subset of P of x. What is P of x? P of x is the set of all subsets of x. Power set. Power set, okay?
Set small set for big set.
Yes,
Power of
yes,
set.
yes. And subsets of
Power set
Yes.
for big set.
yes.
ترى انا ما عرفته.
So for any x,
ترى سهله مره. هذا نقطه من
صح
بحر.
فهمت استاذ صح؟
عرفت هذا نقطه من بحر.
البحر لسه بعد.
البحر من نقطة سهلتها.
وبقي يشتغل ترى اللي 10 ساعات يلا نكمل.
لا ما راد ايش
For any set
حتى 10 ساعات ما تكفي.
x
لا جديات يعني قريت قبل
Let
أسبوع يعني
X
أسبوعين كملت.
be a set, okay? What is p of x equal to the set of all R such that A is a subset of x, okay?
Any set.
All subset of x. Now, this tau is a topology on x whenever we have these three properties. One, empty set and whole of x belong to 2. 2, if we have,
Sequence.
this is not sequence, it is a net, because maybe this is not countable, okay? If this is a countable, we say sequence. This may be uncountable, any element, any number, okay, arbitrary. If we have an arbitrary element in tau, this union must belong to tau. And for any two elements in tau, its intersection must belong to tau. So that for topology, we say that any topology is closed under arbitrary union. Arbitrary union, closed. And closed under finite intersection. Because this is equal to, for any finite element, this intersection belong to 2, okay? This condition, please pay attention. This condition equal to, for any finite number, for example, A1, AN in 2, this intersection AI, I from 1 to N belong to 2, okay?
Yes.
These two are the same, these two are
Yes.
equal,
Yes.
okay? If we have these three properties, we say that tau is a topology and X and tau is a topological space, okay? Tau is a topology whenever we have these three, and X and tau is called a topological space, okay? Topological
Space.
space. And for example, we consider this simple set A, B, C, okay?
Yes.
And tau consider empty set A, B, C, and whole of X. And whole of X, okay? It is very trivial that this is the topology.
On
We
X.
have these three properties because we receive empty set and X in tau, and any union of this set belong to tau and intersection. And also we have for any set X, P of X itself is a topology. If we consider tau equal to whole of P of X, okay? This is a topology.
Yes.
Because any union of subset of X is a subset of X. Any union of subset of X is a subset of X. And also, if we have two elements in tau, it is very trivial that this intersection is a subset of X, so that belong to a P of X. Belong to P of
X.
X, okay? It is very trivial. This topology is called a discrete topology.
Similarity algebra. Similarity algebra.
No, this is not algebra, this is topology.
يعني يشابه وياه في الجبر.
لا تشابهن.
What is
يعني الجبر
your-
مشابه.
اثنين رياضات.
what is the
يعني
question
يشابهن
of-
اثنيناتن ويا معلومات توبولوجي ويا الجبره. نفس القانون.
توبولوجي.
نفس المطالب الثلاثه. نفس المطالب.
No,
لا مو
إن شاء
نفس
الله.
لا
ما إن شاء الله.
this is the definition of topology.
In
Okay,
Java.
this is definition of algebra. These are different.
different.
Two definition different. Okay.
اختلاف داره دکتر.
Yes, yes. This topology is called discrete topology. Okay. Discrete topology.
Discrete topology.
Discrete, yes. And this example is non-discrete topology. Only empty set and X. Okay. This is topology. This is
Yes.
topology.
Yes.
Because any union of these two is if empty set or X, and any intersection of these two
Okay.
is empty set or X. So belong to two. Okay. This is non-discrete topology. Now any topology such as two belong between two extreme cases.
Yes.
Non-discrete or indiscrete and
Discrete.
discrete. Okay.
Yes.
This is discrete topology. This is non-discrete topology.
Yes.
Any topology are between two extreme cases. Okay.
Yes.
So that this is the smallest topology, and this is the greatest or bigger topology. Okay.
Yes.
And note, any topology too is closed under finite intersection. This is definition of closed under finite intersection. Okay.
Yes.
Finite intersection. We say that tau is closed under finite intersection whenever if we have any finite element in number element in tau, its intersection belong to tau. Then we say tau is closed under finite intersection. Okay. Finite intersection. Okay, this is the proof of this. This is the proof of this equality, okay? This is the proof of this equality. Okay, we continue this in harmonic analysis course, but in your operator theory, let X and tau be a topological space, okay?
Yes.
C of X equal to the set of all functions from X to C such that F is continuous. F is continuous. It is very nice that if we have topology, please pay attention. If, for example, let me choose another color such as this. If X and 2X and Y and 2Y are topological spaces. And F from X to Y is a function. Okay?
Continuous or not?
Yeah, the definition of continuity. Functions, then we say F is continuous. Continuous.
Bounded.
No.
If and only if for any open subset in Y, for any V in tau of Y, for example, the inverse image of V as a subset of X be in tau of X. Or equivalently, if V be an open subset of Y is open, then the inverse image of V as a subset of X is open. Please note that any element of topology is called open set, okay?
Yes.
Any element of topology is called open. So that this is called or equivalent by if V be open in Y, the inverse image of V be open, and you know that what is the inverse image, okay? If F from X to Y be a function and V be a subset of Y, we know that the inverse image of V equal to the set of all X in X such that F of X belong to V, okay?
Yes.
The inverse image, so that if, for example, this is X and this is your function F and this is Y, and if you consider a subset of these such as V, okay?
You
What is the inverse image?
inverse.
Maybe this function, this set
V.
minus V. The set of all X such that F of X belong to, so that X belong to the inverse image of V if and only if F of X belong to V. This is the definition of inverse image, okay?
Yes.
For any subset of V, inverse image of V is a subset of X. Is a subset of X. So in topological space we can talk about continuity. If we have topology, we can talk about continuity. It is very important. Let me write this for you.
نقول لك كلش مهمة.
Okay? It is clear?
Continue. Continue.
Continuity, okay? اتصال is continuity in Arabic. پیوسته، okay?
Continuous نه
Conti-
نمیشه یعنی continuity به continuous فرق داری یعنی
No, no. What is معنی پیوستگی continuity چیه تو عربی؟ تو عربی میگی چی؟ تابع پیوسته رو میگی چی؟
continuous
تواصل بين
استمرار
استمرار. Okay. Right, okay. When we have topology, we
Okay.
can talk about استمرار. Okay? Because we need this open sets, okay?
yes
This is definition of continuity. For any element of topology, this inverse image must be topology of X. If we don't have topology, we cannot speak from اتصال or استمرار or continuity, okay? So, you see that at first we assume that X and 2 be a topological space. Because we must talk about continuity.
yes
The set of all F from X to C such that F is continuous. Because we know that X is a topological space and C is a topological space, so we can talk about continuity. And CB of X equal to the set of all F from x to c such that f is continuous and
Bounded.
bounded. Continuous and bounded. Or the set of all f in c of x continuous function such that f is bounded. Okay?
The closed set, دكتور bounded.
Bounded?
The closed sets.
No. F is bounded if we have a real number f from x to c is bounded if and only if there exists an m such that for any x in x, absolute value of f of x is less than or equal. This is the definition of bounded function. Okay, f of x must be less than m. No, cb of x equal to the set of all continuous and bounded function. Okay,
Yes.
continuous and bounded. No, for any f in cb of x, we define the x norm of f equal to the supremum. Because this supremum is finite. This supremum is
Finite.
finite, okay. Understand? We not define this norm in this space because maybe the norm of x in this function equal to infinity because not this function is not bounded. But cb of x is
Bounded.
the set of all continuous and bounded functions. So that all of this, for example, is less than m.
Yes.
So that the supremum is less than m. This is a real number. This is final. cb of x with this is a unital Banach
Banach
algebra
algebra.
similar to L infinity. It is similar to L infinity. And this is the Banach space because if Fn is a Cauchy sequence in cb of x, we have this property. This is the definition of Cauchy sequence. Okay.
Yes. Yes.
For any epsilon, there exists a natural number such as n, such that for any m and n greater or equal n, this norm is less than epsilon. This is the definition of Cauchy
Cauchy
sequence in
sequence.
this norm space. Okay.
Yes.
So that for any x, you must write this. It is better for
yes.
any x in x, f n x minus f m x, not plus. Okay,
Yes.
is less than or equal
F minus.
n minus f n x, because this is the supremum of this object. Okay.
Okay.
Please note that we define this norm equal to the supremum of this object, so that all of this is less than this supremum. This supremum is greater or bigger than all of this object. Okay. F of x is less than this because it is the supremum of this. Okay. This is very trivial that for any x, this is very trivial that for any x in x, f of x is less than or equal this norm because this is the supremum of this object. Okay? This is very trivial. Okay? So that all of this is less than this supremum. This shows that this sequence is a Cauchy sequence in complex numbers. This sequence is a Cauchy sequence in complex numbers. But
Yes.
we know that C is complete
Space.
space, so that this sequence must be converged.
Convergent.
So
in
let
complex.
let this sequence converge to f of x.
Yes.
Because it is very trivial that if we change this x, this limit is changed. So that this must depend on this x. We write f of x. So we have a function such as f from x to c, such that f is continuous and also f is bounded function. For boundedness, let epsilon equal to 1. Okay, this is a non-negative element, so that there exists n1, because you assume that this sequence is Cauchy. Okay, you have this property for any epsilon. No, assume that epsilon equal to 1, so that there exists n natural numbers that we denoted by n1. Okay, for epsilon 1 there exists a natural number such that n1, such that if n be greater or equal n,
No.
this equal to 1, or this less than 1. It shows that we have this inequality, and also f of x is less than this. This is finite or bounded. Okay,
Yes.
so this norm is bounded. So f is bounded, is a bounded function, and also f is continuous. It is trivial, and also this is a very easy consequence of triangle inequality. You use this in any norm space. This is very important, dear students. This triangle inequality, okay, in any norm space, if x with this is a norm space, okay,
Yes.
then for any x and y, in x we have this inequality. This is triangle inequality.
X plus normal y.
Okay, this shows that for any x we can write the norm of x equal to the norm of x minus y plus y. Okay,
0.
this is 0. This is less than or equal
Select
first
X.
the norm of first plus the norm of second. Okay,
Y.
موجز.
if you move this in this side, we see that the norm of x minus the norm of y is less than or equal the norm of x minus y. Okay,
Yes.
and also we can apply this for y. This is equal to the norm of y minus x plus x, and this is less than or equal the norm of y
Minus
minus x plus
plus
the
norm
norm
x.
of x, and so the norm of y minus the norm of x is less than or equal this, and this is equal to the norm of x minus y. Okay, the norm of x minus y equal to the norm of y minus x,
It's equal.
equal, so that we have these two. These two shows that the absolute value of the norm of x minus the norm of y, the absolute value, okay,
Yes.
is less than or equal
Normal x minus y.
x minus y. This is a consequence of triangle inequality, and this is very important, because this less than this and is minus negative is less than, so that the absolute value, because the absolute value of this is or this or this, is this or it's negative. Okay, so that this absolute value must be less than. This is hold in all norm space. In all norm space. We prove this in this spatial norm space. Okay? We can write this and this, so that we have this. The absolute value of this subtraction is less than or equal the norm of this subtraction. It is trivial that CB of x is a subset of it, This is the bonded element of C of X, okay? But if X is compact, then CB of X equal to C of X. Because if f be a continuous function and X is compact, f must be bonded.
Yes.
Because we know that if f be a continuous function and X be compact, f of X is also compact. And any compact set is a bonded set, okay?
Yes, yes.
So that f must be bonded.
And compact is bounded.
Yes. Okay. Let me write some sentences for you.
بيك مرتضى جيتني؟ لا احتياط وين تسوي؟ والله ما قصر الدكتور
Okay. It is trivial. مرتضى it is in مفهوم جمله.
مفهوم
در
دكتور.
این جلسه من سعی کردم طرز فهم اجازه نمیشه. بله دکتر.
In Arabic, not for
عربی دیگه
In
متوجه
Arabic,
في هذا الاجتماع أنا أتعلم كيف أقرأ
كيف أقرأ أوكي؟
نعم.
اوکی
اوکی.
تموم امروز یا نه دکتر؟
میتونیم چند دقیقه استراحت کنیم.
اوکی اوکی
تفهمني والله العظيم عبالك من قلبي
وقف انت ترى.
میرم بیرون دیگه دکتر.
آره.
فردا انشالله هم هست.
Yes.
امتحان میشه دست فردا.
بس.
هارمونیک یا اپریتور؟
مشغل
بس فردا اوپراتور.
اوکی.
Please write your name.
اسمك وتوقيعك.
من
ايه اسمك وتوقيعك على حضوره.
شماره من
يعني نسجل اسامينا كلنا واحنا نوقف. اقول لك شوف شو اسمه اوكي التسجيل منا هاي شوف الصورة اوكي تشيكل شو اسمها
الخاشوقة طب المصفر.
هسه انا شعلي بالخاشوق كذا انا اعملها اوكي نسجل اسمه.
اي زين
Please write your name.
نشوفها والله انت شغلتك
لا زين زين.
اوكي
بقیه کجا رفتن؟ نمیدونم.
نمیدونم دکتر. فکر کنم دستشویی.
سجلت.
دکتر بشه کار داره.
چی میگه اون؟
کپی میخوایم. بله.
المصدر
کتاب مال شما.
يفيدنا مستقبلا.
مفید. در زرد کن. زرد درسته؟ نداره.
غسان طيار المستقبل بين ما يجون الولد.
نداره میگه.
چرا؟ تو گروه فرستادن.
يعني مفيد
مفيد عندنا دكتور مفيد من نروح العراق مفيد
من تقو
Yes, I sent to you. من فرستادم تو گروه فرستادم.
محاضرات مال شما؟ نه. کتاب اصلی.
کتاب از
بله.
بالي
مو بس التحليل حتى المشغل.
اي
المشغل باو المشغل ترى مصدرين. اخذ نص مصدر والمصدر الثاني ترى ما موجود اصلا.
دکتر بخشید چند سوال تو امتحان؟ نزدیک مثلا 6 بعد اینجوری؟
ته نکردم. به اندازه کافی سوال
سوال كمان
نگران نباش. دیدی وقتی آشپزی آموزش میدن میگن مثلا نمک به اندازه کافی.
بله نه دکتر نمک مال شما خوبه انشاءالله.
آره.
5 سوال که بس.
فلفل 5 تا
5 تا خوبه.
این اگه تعداد سوالات بیشتر باشه به نفع شماست. مثلا اگه مثلا 5 تا باشه یه سوال ننویسی 4 نمره از دست داری.
4 نمره هر
5 تا بیشتر. از 20 بخواد حساب بکنیم
10 درجه مثلا.
حالا 10 داره.
خب
2 نمره از دست داری.
2 نمره.
یعنی اگه مثلا 10 تا سوال باشه یه نمره از دست داری.
يا چند درجة؟
شما چی میگه؟ نظر شما کی بهتره؟ 5 یا 10؟
من این کار میکنم به نفع شما باشه. نگران نباش.
ممنون دکتر. من فقط به خاطر این کورس این میخوام گیر میکنم.
نه انشالله.
شنو صار شنو؟
متاسفم.
أقول لك
Okay, this is definition of topology, okay? I recall this in the previous session. A subset of P of X.
ثانية
It's called a topology if we have these three
أصلاً.
properties.
الواقع نسجل أساميهم نسجل أساميكم
Right to here. For example,
نسجل أساميكم
this is an example, okay?
نسجل أساميكم مكانكم قال لي يجوا
Let x equal to r, real numbers, and tau equal to this union. The union of intervals, okay? Union of intervals. These are intervals. You say in Arabic what is the قوس or interval? قوس, okay?
فترة انترفال فترة
For example,
نسميها فترة.
مو هو قال لك اقواس.
أقواس
شو معناها بالعربي؟
لا قال هو قال قوس صحيح. اوكي
okay? The union of these intervals, okay? Such that this is an open interval. Open interval, okay? Then, or in r to the power of n, we can consider these two product of intervals, okay? These two are topology. This is a topology on R and this is a topology on Rn.
والله يا جواد أحسن مني.
We prove this for you. Let this is the definition. Let tau be a topology. A belong to tau if and only if A is an open set, okay?
شوف التطبيق.
And X and tau is called a topological space. These are example. Thank you. These are example. For example,
طلب من هذا. بالنس.
X equal to R and to the set of all subset of R such that A equal to the union of intervals, okay? The union of intervals. Open intervals. Then tau is a topology on R. For topology, we must check three properties, okay?
Yes.
At the first, we see that empty set belong to tau because we can consider this index set equal to empty set, okay? If I equal to empty set, this union equal to empty set. Empty. مجموعة خالي توهي. Okay? So that empty set belong to 2. And whole of R equal to this union. It is very trivial. The union of these intervals equal to whole of R. Is it trivial or not? Please note that if we consider this as, for example, real line, this is, for example, interval -1, 1.
One.
Then minus
two.
2,
minus
2.
لا
No, minus two.
Minus
ثلاثة يا
3,
ثلاثة
3. Okay?
تقريبا.
What is the union of
Sorry.
all of this? Okay?
Yes.
And from 1 up to the infinity. It is equal to whole of
Minus
R. Okay? It is the union of all of this.
Well,
So that this is an element of this topology. So we have the first condition, empty set and R belong to this tau, this subset of P of X. 2, if we consider a family in tau, we must prove that the union of this family belong to tau, okay? But what is tau?
Topology.
What is tau? This topology consists of all subset of R such that R is a union of intervals, so that all of these must be a union of intervals, okay?
good.
For any I in J, I is an element of tau, and tau is this set, so that there exists a family of intervals such as this, such as AI equal to this union, okay? All of these must be a union of intervals, okay? All of this AI must be a union of intervals. So that the union of this family equal to the union of these families, because AI equal to this, okay? The union I equal to J, AI equal to the union I equal to J, these unions. And this is a union of intervals again, okay? This is a new union of intervals. So that this is an element of tau. Please pay attention. Tau equal to the set of all subset
R.
such that A can be written as a union of intervals.
Yes.
And this set can be written as a union of intervals, so that this is an element of tau.
Yes.
So that for any family of tau, its union is a family of tau, is an element of tau, so that this family is closed under arbitrary union. And second property, if we consider two elements in our set tau, there exist two families such as, for example, this family of intervals and this, okay? Such that A1 can be considered the union of intervals such as this, and A2 also the union of intervals. Then we see that the intersection of A1 and A2 is the intersection of this union and this union, okay?
Yes.
And this is equal to this union, and this interval intersect with this interval. But we know that the intersection of two interval is an interval. I specify this, okay?
Yes.
This may be empty set or an interval, okay? So that this is an union of intervals, so that this must be belong to tau. This must belong to tau. So that if we define to the set of all subsets in R such that A can be written as a union of intervals, this is a topology. These have these three properties, okay? These three properties. Empty set and whole of R belong to 2. For any family in 2, its union belong to 2, and for any two element in 2, the intersection of A1 and A2 belong to 2. We have these three property, and so this is an example of topology on R. And also we can consider x equal to R to the power of n and 2 equal to the set of all
جواب دكتور مشكلة
زيادة union of open intervals in Rn. What is the open intervals in Rn? These sets are open intervals in Rn, okay? Please note that if n equal to 1, open interval is AB, interval such as this. If n equal to, this is an open interval. A1 B1 multiplied by A2 B2. If n equal to 3, we have this cube without boundary, okay? And all dimension can be considered such as this. This is an open interval in Rn. For example, this topology is called Euclidean topology, okay? If you consider this topology, this is Euclidean topology on R. Euclidean topology, or this on Rn, this is Euclidean topology on Rn, okay? Example, this interval in the Euclidean topology is open because we can consider 1 up to the infinity equal to this union. It is trivial. 1, 2, 1, 3, 1, 4, okay?
Yes.
What is the union of all of this union? All of this interval is equal to 1 and infinity. Or for example, this is open in Euclidean topology because we can write this set equal to this union. Radical 2 minus n and radical 2. If we consider n equal to 1, 2, 3,
Yes, sir.
we tend to minus infinity, okay?
Yes, sir.
For example,
Yes, sir.
this is an open set. This is a member of our topology because all of these are interval, okay?
Yes.
So that this union must belong to our topology.
It's open.
It's open. The union of this interval must be belong to 2. And R minus Z is open because this is R minus Z is integer number, okay? 1, 2, 3, 4, or minus 1, minus 2, and 0. R minus Z equal to this. You must remove integer, okay? So remind these intervals, okay? These intervals. R minus Z equal to this union, and this union must be belong to 2. So that this is an open set. All of these are open. And so Z is closed in any topology if X and tau is a topological space A belongs to tau if and only if A is open, okay? And A is closed if and only if the complement of A is open, okay?
معكوس.
For as an example, this is open set, so that Z must be closed set.
Close itself.
Closed set. Okay? And in harmonic analysis, I think we begin with this book. We begin with this book. Maybe with this. Okay? We begin with this book.
المصدر هذا أساسه.
لازم نجدد شو محتاج لنا مصدر.
This is the definition of topology and discrete topology, non-discrete topology, Euclidean topology, okay?
Yes.
The element of Euclidean topology on Rn are unions of open balls, okay? In Rn. This topology is denoted by this. A special case that we will make constant reference to is a here open set or union of open intervals, and a set X together with a topology form a topological space and denoted by X and 2. And this is the definition of neighborhood,
الجوار.
a jawar. In any topological space, if X belongs to X, a set N is a neighborhood of X if there exists an open set,
Yes.
an element of tau with this property. X belongs to U, U and U is a subset of N. In other words, N is a set that contains an open set containing X. And the set of all neighborhoods of an element X will be denoted by Nx. Examples. This is the example. This is example. For example, this is the neighborhood of 2. This is interval 1, 3, okay? It's a neighborhood of 2 because 2 belongs to this open set. This is open set, okay?
Open set.
And this is a subset of or N, okay?
Yes.
Please pay attention to this.
أبغشي.
Murtaza,
Yeah.
X must be belonging to an open set, and this open set must be a subset of or set, okay? X belongs to U, U be a subset of N. And we see that in this example, 2 belongs to this open set, and this open set is a subset of or set N, okay? So that this N is a neighborhood of 2. You can see that this 2 is an element of this open set, and this open set is a subset of or set. So that this is the neighborhood of 2. Okay? Okay? Or for example, this is the neighborhood of 3 because 3 belong to this open set, and this open set is a subset of our set. It is very trivial, okay? Because
يعني interval.
for example, if we consider for this 2 and infinity, okay?
مو علاقة مع السنة.
This or set n, for example, and we see 3 is in this open set, okay?
Yes.
3 belong to this open set, and this open set is a subset of all
تمام تمام.
n,
تمام ان شاء الله.
okay?
تمام.
So that this is our u, for example, and this is our set n. X belong to u be a subset of n. Mr. Al-Khafwaji,
نعم دكتور.
it is trivial.
بس مرتبط.
X belong to u be a subset of
الواحد
U.
مقيد
Okay.
إلى الأكثر. ما يصير بالعكس.
translate.
برقات مية.
ليش أصلا؟
يعني
يعني
بالعكس.
شو هنا؟ مثلا
ماينس ما نهاية.
minus
ماينس انفينيتي.
or 1 to 1 neighborhood 2.
Let me write.
هو جاي.
Okay. Which minus?
ماينس انفينيتي.
Okay.
minus infinity
Yes,
to
yes,
1.
yes.
Neighborhood.
قليل عاد وصل له ساعة.
For example,
لا لا بالعكس.
الجهة الثانية راح تصير. الجهة الثانية.
you may consider this, okay?
تمام.
Okay? This set
رايتها
is a neighborhood of, for example, 2, 3, 4, not 3, 4. Okay? For example, 1.
راح تصير من
For example, 0. Okay?
عكس دي كانت
بيوان نمشي
No.
بيرون
Zero.
interval.
شو بعدين؟
مفتوحة
For example, you can consider 1 is an element of this open set.
تمام هي
Minus
تماما
2 open, okay? And this is the subset of minus
شوف بس
infinity
هذا
and
كتب صفر
close.
واحد اثنين بيرون
This
صفر
is
شي يجي
all
واحد والصفر والتحت
and
الصفر.
this is
لا هسه
all
عندك هذا صفر
neighbor.
هذا صفر
بس عربي
ورا صفر شي يجي
بعدات
ورا الواحد
اكثر.
ستة واحد صفر واحد اثنين
واحد شاكر.
Okay?
والله مو جاي غش شد بس جاي صح مو
And
قول صحيح.
the set of all neighborhoods of an element will be denoted by n x, so that you can write, for example, minus infinity 2 is an element of n of 1.
1.
Okay?
Yes.
Or in,
Neighborhood 1.
yes, in previous
النقطة الأولى المجاورة.
example, or in this, we can write, for example, this interval to infinity is a neighborhood of 3, okay?
تمام.
Neighborhood of 3. And I
وين الان اثنين؟
recall that A is closed if and only if the complement of A is open.
أخذ على الثلاثة رقم اثنين.
So that A is closed if and only if the complement of A belong to 2, because these two are the same, okay? For example, Z is closed in Euclidean topology because we see that the complement of Z is open, so that Z is closed.
على الار ما عدا الزد
Z is integer number.
ايفلي ار ما عدا الزد نفس الشيء كومبلمنت ولا ار ما عدا الزد يعني الا بالفصحى
and
لا جديات.
this set is closed. This set is closed because this is an open set. Okay?
Complement.
Ahsan. And this is the complement of this set. The complement of this set equal to r minus this, and exactly equal to this. Okay?
Yes.
For example, if you consider this set, what is the complement of this? Is this set, okay? So that this is a closed set because its complement is open set.
شو هذه؟ R معادل واحد والإنفينيتي تساوي
And
سالب
the
بواحد.
product of z by itself is
No.
closed in R2 because R2 minus this set is open.
Open.
This is R2 minus because all of these are open, okay?
Yes.
So that its union is open.
Very open.
This is open, so that this is must be
Closed.
closed.
Close.
Okay?
Complement.
Yes. Its complement must be open. This is another example. This singleton is closed with Euclidean topology because the complement of this singleton is this union of these two open interval. Okay?
Yes. Subset.
It's very trivial.
متجاوزتين واحدة من
صورة مالتها.
You can also-
تعطيك كذا لك واحدة ولا واحدة. والله شكرا معليش والله يزيدها.
For example, if we consider
يا بنت هو.
this as radical 3, what is the complement of this? This open interval and this open interval, okay?
Yes.
This and
Yes.
this. All of these are open, so that the union of these two are open, okay? The union of these two open is open set, so that this is the open, so the complement of this set is open, so that this set must be closed. And any finite set in R is closed, because if A be this finite set,
AN.
AN, for example, A1, A2 up to AN, by this order, we can consider R minus A equal to this union. It is very trivial.
Minus A.
R minus A equal to
Open.
this open set. This is very trivial because we see, for example, we can consider, for example, if we consider
لا بس قبل لا
This
لا،
order-
لازم نسأل باكر الحل ولا
we consider this order A equal to A1, A2,
أي
AN with this order. A1 is less than A2, less than AN. What is the complement of A? For example, this is
A1,
A1,
A2,
A2,
أي أي
A3, and
AN.
finally
أي
Its complement consists of this interval minus
Minus
infinity
A1.
up to A1.
Minus A1, minus A2.
Ahsan. And
minus-
then A1 to A2,
لا لا open.
A2, A3, and finally
أول واحد
AN
حصل
up to the infinity.
and
Okay?
infinite.
So that this is equal to minus infinity A1 union by A1, A2 union by,
أي 2 أي 3
and finally we can write AN minus 1 AN, and finally
This is open.
AN up to the infinity.
That's
Open. This is open.
Doctor,
All of
excuse
these
me.
are open.
Excuse me, Doctor. We can't say this. What this group?
All of these are open, okay?
Open or closed?
No, all of these are open.
Why open? Because it's finite. Also finite. union of this interval
Yes.
also infinite.
In the definition of topology, we say the union of any element, okay?
Any element.
Finite, infinite, okay?
Okay.
This is finite number. But if these elements are infinite, again this union is open.
Before this example, you say is open because closed because it's finite. Interval finite.
No. For example, I write some example for you. For example, I have this example. Please see.
Yes, and this.
For example, I write for you that this is an open set. This is an open set. Okay. Minus infinity radical 2 is open because we
Okay.
can write this as a union of open intervals. Okay.
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 We can say any infinite group is closed or open. Maybe closed, maybe open.
No, if this bond is open, this is an open interval.
Okay.
لو
Okay.
جبت مفتوحات ولا
If it is closed, it is closed.
Oh,
Okay.
okay.
And
يعني تحديد النقطة
So-
تعتمد راح تحسب.
نعم.
in this case,
إذا تجي
we see
من
that
open
all of
open.
this is open,
إيه،
so
إيه،
that
النقطة اللي
this
تقدر.
is
أول اللي
an
راح
open
تصير
set.
ما حصلت.
This shows that A must be closed. Okay.
Yes.
So that any closed set, any finite set is closed. I write for you, any finite set is closed, okay? Any finite set in R is closed. Any finite set is closed.
Ready?
Okay. Example, in discrete topology, what is discrete topology? Rule of P of X. Please note that discrete topology is P of X, okay?
Power of it.
Power.
Power of X. Any topology belong between two.
Products.
This is T. Discrete topology is indiscrete topology. okay?
Yes.
Now, if we consider discrete topology,
تمام. هذا
Okay.
الأساس البي إكس.
in discrete topology, any subset is open. Okay? Because any subset of X belongs to P of X. So that any subset is open.
Okay. Okay.
So that any subset must be closed.
Really?
Any subset must be closed. Because for any subset of X,
Yes.
A belongs to two so that A is open. Okay?
Yes.
And for any subset of X, the complement of F is a subset of X again. So that must be belong to P of X. So
Yeah.
that must be
Closed.
open.
Yes.
X minus F must be open. So that F must be closed.
Yes.
So that in discrete topology, any subset is open and any subset is closed. It is very, very
close إجابة السؤال.
nice example.
تمام.
Okay?
إذا إن شاء الله منها أنسى.
This is an extreme case.
الإف أي
إكس
عنصر.
الراء. هذا إكس بخمسة.
But in discrete topology,
أي.
what is the open and closed set in indiscrete topology? In this topology, only empty set and X are open. Only empty set and
Empty
X
set.
in this topology are open. And
this-
so only empty set and X is closed. In this topology,
Because don't have two.
because if we can write if in this topology, okay,
But
if A be closed, okay, is closed, this shows that X minus A is open, okay,
yes.
is open, meaning that this must be belong to this topology, okay.
On X.
So we have two cases.
X.
So we have two cases. One,
Yeah.
X minus A equal to empty set, x minus a equal to whole of x.
Yes.
Yes.
If we have this, a must be equal to x, okay?
87.
If we have this, we must have a equal to
X.
empty set,
5.
okay?
Five.
Empty set.
Yes.
So that if a is closed set, a must be equal
Equal
to x,
x.
or a must be equal to empty set. Okay?
Yes.
Only closed set in this topology is empty set and x, and any open set is empty set or x. But in this topology, all subsets are open and all subsets are
Mm-hmm.
closed. Okay. Okay, I write this again. F is closed, then the complement of F must be open, must be in our topology. But our topology is empty set or X, so that X minus F is empty set or X, so that F must be equal to empty set or X only. And we write this. Remark for you, by the definition of topology
Open set
and
closed.
open and closed set, we have these properties.
5.
Empty set and X are open set because we know that empty set and X
Yes.
are belong into
Yes.
in all topology. In all topology, okay? Two, any unions of open sets are open set
Formal.
because any union of element of two must belong to two. Any finite intersections of open set is open set.
Okay.
Property 3,
Yes.
okay, in topology.
Yes.
A closing is like
The any intersection of
Close.
closed sets
And the close.
is closed
Also
set.
closed.
And in any finite union of closed set is closed set. We must prove only D and E, okay? Because these three are definition of topology.
yes.
For D, let Fa is a family of closed set. D, any intersection. So that this I is arbitrary. What is arbitrary in Arabic, Murtaza?
Arbitrary.
Arbitrary?
Arbitrary.
In Persian we say delkha or arbitrary.
لا شيء عربي.
In Arabic, let me
Arbitrary.
translate.
معتمد.
لا تنفع تدريب العصبي.
أكثر القلب.
Not marbut.
لا.
No.
معتمد معتمد.
معتمد معتمد هو اللي قصد.
أي رقم okay.
أي عربي.
All elements.
أوكي.
Okay.
أوكي.
Trivial.
أوكي.
We say any intersection. Any. Okay. So that
كل تقاطع.
call. This I must be finite or infinite. Must be countable or incountable.
Yes.
Any number. Any number, okay? This is a family of closed set
Close.
in X. Then the complement of this intersection. We know De Morgan property, okay? Do you remember
So
De
it's a
Morgan
hard-
property?
Yes.
The complement
Yeah,
of
I think
intersection
yes.
equal to the union of
تمام.
X minus.
complements, okay?
Complement.
Complement. No, it is very, very nice that all of this Fa is closed, so that all of these complements must be open. Since Fa, F alpha is closed, the complement of F alpha must be open, so that all of this is open.
Complement.
complement.
its complement
Yeah.
must be open.
Yes.
And we know that any union of open set is open.
صورة.
So that this union must be open. This must be open. So that this must be open. So the complement of this intersection is open. Oh,
خدا تعالی
don't worry.
مثل عراق شد دیگه قرار
اینجا سریع میاد.
ها
دكتور ما تشيل امتحان قول له علي قول له ما تشيل امتحان
No. The complement of this intersection is open. So that itself must be closed.
اقرا اللي قلت
ببخشید
الله
آب
يسلمك.
هم نیست دیروز
آبدار
بله تهران آب نیست
تهران؟
يلا علي سأله ما تشيل امتحان
امتحان باكر
بس
شوي.
ولا يسأل انا اريد اقول له هاي
اینجا
سأل
يا اخي شنو المشكلة
تهران من
عندك؟
بودم
جاب لك
تو
باكر ما
يا اخي شنو المشكلة
شوف ذيك ورا كلنا
Let me
مسجل
write for you.
الامتحان امتحان
والله ما
الجلسات
أدري. شنو المشكلة
مالتنا
ما اعرف
الجلسات والامتحان
لا لا حسين
كلنا مسجل
لا بس اليوم
22.
3 مرات قالت باكر مو امتحان.
شوف الدم
باكر
انجليزي لو
باكر مو امتحان باكر نظرية
بس نسأل
مسجل
العلاوي
F
رامي
alpha
باكر مشغل مباشر مشغل
شغل باكر.
لا انا ما سألت
be a family of closed set, okay?
استاذ محمد اه خطأ
Okay? Closed set. We consider this complement. This is equal to the union of this is De Morgan property. De Morgan. But for each alpha, this F alpha is closed, so that this is open, okay?
يس كومبلي
So that this union must be,
Also open.
so that this is an open set.
يس
This is equal to this.
يس
تمام.
This shows that this intersection must
Yes.
be closed.
Close.
كومبلي
Complement.
So that for any family of closed set,
Close.
the intersection of this family must be
Close.
okay?
Yes.
And
proof D
proof D, yes. And what is E? I think any
any finite union
finite union
Close.
of
close it
closed set
yes
is closed, okay?
yes
Finite. And for this, let's we consider a finite family, okay? Such as, for example, C1, Cn. Be a finite family of closed set.
طيب قدامك الكرسي ما تطلع شو اسمه هذا.
Then we consider the complement of this union. See I, for example, I from 1. This is equal to the intersection of x minus 1, okay? And this is the Morgan property again for finite numbers. But all of this is closed, so that all of this is open, okay?
yes intersection of
And this is open because this is because this is finite number.
Yes.
Okay? This is finite number.
yes
So this must be an open set. This is open set so that itself is closed. Okay?
Yes.
So that this union is closed. And these properties are very nice in topological space. Any finite union of closed set is closed. Okay? Yeah.
شو خاموشي عندي؟
Okay.
سبحان الله. كلمة بدون شيء بس درجتين واشتغل.
نخشي عفوا استلم الموضوع.
شارمان ده أحد.
نشوف هاي مضبوطة صارت.
عبود شو ما البعروق قابل قدرته
قال لو قدرتك. يعني
قابل
داعم
البعروق
انت قاعد بمحاضرة مرتبط عن استاذك قديم ولا كان شنو السؤال؟
Okay? Any intersection, any of closed set is closed set, and any finite union of closed set is closed set.
بس احلى طريقة تدريس. لا
في ماركين
ان شاء الله خطوات
في مارك
تصوير اليوتيوب.
هاي لو عندنا بالمدرسة
This is the definition of
طبعا.
closure.
قاعد تشرح.
Okay?
نعم.
كلوجر
Closure of a set.
Yes.
Let X and tau be a topological space and S be a subset of X.
ليش هذا؟
Then the closure of S equal to the intersection of all F such that F is a closed set and F containing S. Okay? The intersection of all F such that F is closed and S be a subset of F. And we have this regard for any set or subset S of X. S bar is always closed. For what? Because S bar is an intersection of closed set. Whatever, all of this must be closed, okay? All of this F must be closed. So that this intersection must be closed. We proved that in the previous. Any intersection of closed set is closed. Okay?
سيت اف يعني اف سيت مش درستي؟
Yes. Yes. This is a closed set.
يس
And this intersection must be closed. So that S bar always is closed. S may be closed or not closed. But S bar is always a closed set. And S is a subset of S bar. Because all of these contain S. Okay?
يس
All of this containing S. So that this intersection must contain S. S is a subset of S bar. And also we have this for any closed set containing S. S bar is a subset of S. S bar is a subset of all of this F. Okay? Because S bar is the intersection of this. Intersection of family is a subset of all member of this family. It is very trivial, okay?
يس
For example, for two set, we say that, for example, this intersection is a subset of A1 and is a subset of A2, okay? And for any family, this intersection is a subset of A alpha for any alpha, okay? And in S bar is the intersection of F such that F is closed and containing S. So that all of these must be contain S bar. S bar is a subset of F, okay?
Yes.
So we have this property. So S bar is the smallest, okay? Is the smallest closed set such that contain S.
اس بار يعني
والله
The closure of S.
closure.
Yes, the
والله
closure
العظيم
of
اول
S.
مره اشوف الرياضه
F. This is F.
بس اول مره اشوفها
This is
bar.
X.
خلطنا
This
بكل
is all X. No, this is S.
موجود
بدون
يقول الصوره
This
فيها
is-
مرحلة أستاذ محمد. أستاذ محمد
وين؟
فيها مرحلة
The
خدناها.
complement of N, okay?
والله يمكن
This
بالثالث
is the complement of N.
هي
لا ما ماخذينها
Yes.
لا لا بالثالث
And
شنو ما ماخذ؟
we prove for you
ثالث او رابع يمكن يمكن
this
بالأقل.
property
يمكن
that
بالأقل. يمكن بالأقل.
we can write S bar equal to this set, okay? If we consider the set of all X such that for any neighborhood, this is the notation of neighborhood, okay? This intersection be non-empty set, this S bar equal to this S tilde.
اصبر شنو؟
And we prove this for you. This proof is not
اصبر
اكس بار
اصبر يعني شنو؟
كل
Closure.
سكشن مال الاف تقاطعات مال كل اف
دكتور ياكشي
اسمها اكس بار
اكس بار
لو
بس
بار.
انشي
بار
this is
يا
this
بار.
is a new set, okay?
Mm.
But we prove
Yeah.
that
بس والله
S bar equal to S mat, okay?
مات
Smart.
لا
Okay.
خلص من
Or-
الطالع
or
جاء
S
كلام
tilde.
ثاني.
Tilde.
اوكي
S tilde, okay?
تقدر تسوي بار.
Yes. These two are equal.
رموز
يعني كل يوم يسمى شيء.
And we prove this for you, okay?
يس
نعم.
If X not belong to S bar, we have this because or S tilde.
Yes.
If X belong to S tilde, for any n we must have this property. So that if X not belong to S tilde, there exists a neighborhood
اكس
such that this
نون
intersection be equal to empty set.
Yes.
And this shows that S must be
اكس ماينس ان
a subset of X minus n. I write this,
شوف هذا.
please note that if these two sets are this shown, okay?
نعم
The intersection of n and s be empty set, then this s must be a subset of the complement of n, okay? This is the complement of n. Murtada, do you know?
لو قاعد-
This is or set n. This is the complement of n, okay? Complement.
مجموعة ان وهذا البراء هذا
مكملة مال
مكمل. أحسن. If these two sets are disjoint, S must be a subset of the complement of it, okay? The complement of it. And by the definition of neighborhood, there exists an open set by this property.
نعم.
Do you remember?
لا أحمد شلون بطولة-
This is the
بطولة-
definition of
بطولة-
neighborhood.
تعريف.
بطولة عدة.
Yes, تعريف.
حيدر.
And this shows that x minus n is a subset of x minus u, and this is a closed set because u is an open set.
يو شي يعني
U an open set
اوكي
because belong to 2. Okay?
يس
So that S bar must be belong to this closed set by this property. Okay?
يس
For any closed set containing this, S bar must be belong to if be a subset of this, and this shows that X not belong. This is very nice that if X not belong to S bar, S tilde, S not belong to S bar.
اكس بار يس
And we have this equality.
because
P implies Q equal to
yes
negation of Q implies negation
negation
of
of
Q.
P yes
And also we have this, so that these two sets are the same, okay? These two sets are the
صف رابع علمي صار نعمل هذا
الرابع نعم
منطق الرياضة
صحيح
yes, yes.
هو
The same
موضوع
mantle
هو
of
بس
the
هو
other.
الموضوع
جدع وفقت إيدها.
هو شو شو أدمى معطيك العبارات الصائبة والخاطئة.
إنه
هو بس هذا
بس
الموضوع.
هو منطق رياضي
ده شغلات موجودة بالرابع.
لوجيك ان ماثماتيكال.
And also
إيه إف عنده ألف هاي موجود.
in this book we have the definition of dense subset. What is the dense subset? This is the definition of closure, okay?
Yes.
And closure equal to the I denoted this by S tilde and proved that S tilde equal to S bar.
Yes.
Okay. Let X and tau be a topological space. We say that a set D is dense in X when the closure of D equal to X.
بالعربي يعني كثيف.
Dense.
كثيف. كثيف. مجموعة الكثيف اسمه.
The closure of D equal to whole of X. Okay? Let me write again for you. In a topological space.
أنا شو أسوي أنا سجلت تكتبين؟
ملاحظات مفيدة الوتيت اللي خاف تكبير.
شنو هذا؟ إيه شنو؟
Dense. In Persian,
وش اسمه؟
we call
محببة؟
Shagab. In Arabic, let me write.
لا لا صدق وش اسمه؟ إسبان. شو يقولوا؟
هو اصبار لا اكسبار.
Oh, كثيف.
كثيفة.
شقاق.
خير ممنون.
شو اسمه ببخشي؟
ببخشين فقدين ببخشين بلدي.
Okay?
صدق على شو كيف؟
هل موجود؟
صدق.
أقول
ليش
نطلع
أوكي؟
الورقة فانا ونطلع.
Let
بس لا ناخذ شو اسمه؟
إذا بعد يمك اشتراك في الورقة فانا واطلع.
X
اعتمد عليك فوق.
تعتمد عليه؟
هذا على الله وعلى
be a
محمد.
topological
والله
space.
العظيم.
عم الشاطر معتمد عليه وانا اعتمد عليك.
هو راح يصير اكسبار علينا كلوز كلنا نفس لا تخاف.
لا خلوني ما افتح المرجع.
And D be a subset of X. Okay?
Dense.
D is called
أستاذ حمد.
Dense.
Sorry.
كثيف.
a
وين؟
dense subset of X whenever
وش لعبة؟ قاعد
the closure of D equal to whole of X.
ها. Closure dense equal X.
Yes, and a very nice example is this. Q is dense in real numbers. If we consider this with Euclidean topology, okay? With Euclidean topology. And you see that? This is it there.
یعنی دانشجوتون هم هست با تأخیر اومده بگه
بگو بیا تو.
موجود.
السلام عليكم.
السلام عليكم. تفضل. انت دانشجو اسمه شو؟
السلام عليكم. السلام عليكم. ويانته
مرحلة ثالثة
شو اسمك؟
ناجح مالك.
ناجح مالك.
انضفت مؤخرا دكتور.
اوكي.
يعني من العام انا من الكورس الثالث حملت عندنا المادة.
كورس كورس فيش دكتور مادين.
اها.
هذا ما امتحن.
دوره قبلیه.
این دوره قدیمی.
دوره قبلی
قناه داره تفضل الاستاذ العزيز الله يحفظك الله ابو الخير طبعا دكتور منشوي
این چایی؟
ببخش شرمنده خیلی ممنون
یه کاپوچینو.
نه کاپوچینو نمیخوام قندک داری انا ببخش
بندمونو.
استاذ محمد چای اصل به
لا ما اعرف. تسلم.
لا لا ما دخلت اسال عينك.
ويلكم.
لا
این خالیه دکتر
يا خليل.
ليش تسال؟
دكتور.
No, where's
Excuse me, Doctor. Tomorrow we have also lecture
Yes,
or
yes.
final
Yes.
lecture.
We have also lecture and your exam in
Pass
operator
further.
theory is pass further.
باس فيرذر اوكي
بدون
نقدر بعشرة امتحان.
زين السلام قول له السلام يريد ما يجي امتحان مريض الحشر شو اسمه يقول اكو دور ثاني لا سلام
سواء خلينا
What I
نرجع.
say to you?
غسان
ألفا.
لا باكر
دكتور excuse me one student from us اسمه عبد السلام طاهر من دونه
Yes,
is, cannot come to Iran in this time because have many work in her office. He asked me for asking you about have an terrible exam or secondary exam after that or no.
I don't know because this is university law, okay?
Yes.
This is university law.
Yeah.
Maybe university not accept this that we have another example in another time.
Okay.
Please say to Abdul Salam that we he must coming in Iran in the time of your exam. Okay?
If cannot come in,
I don't know. I don't know. Maybe
take the course again.
yes.
Okay.
Maybe.
Fine.
Maybe.
شنو؟ يقول لك لحد الان انا ما ادري زين بس احتمال اكو
Okay, this is an example. Q
يقول لها
is
الكورس
dense
الجاي.
in R. Okay?
عبد الرحمن
يعني يسوي لك
شنو؟
جديد.
Q is dense in R. The closure of Q.
وين سكتنا داري
Q is
انت شنو؟
Q is the irrational number. Okay, what is Q? Irrational number. You know that
وين اكو كورس ثاني؟
in
اكو كورس ثاني
subset of real line, we have natural numbers. Okay. Okay, million
تريبل دقيقة دكتور
integer numbers. -3, -2, -1, 0, 1,
infinite.
2, 3. And this is irrational numbers, the set of all the
أعداد نسبية
yes, A belong to Z for example, B belong to N. Okay?
we
Because this not equal to 0.
بعد
Okay?
أقل B equal 0 كم غير معرف indifferent
يعني يبدا من الصفر احنا بالمدارس
Irrational number.
هناك تنزل
ها
هناك إلى زد أي وبي بس يقول لك بي لا تساوي
لا يساوي
B لا تساوي
صار
صفر.
صار بس
بس هو
مقام
استخدم
كلمة.
زينة
لا قال
شربي
كمية غير معروفة
قال كلمة أستاذنا الجليل تفضل كيف
لا شو
صار مديدة
وين
الكيف.
And the closure of
مزن ترى اسمع هذا خوش كيف ما شيء يكون هذا
okay, the closure of Q equal to real line.
تقدر والله شيء
Yeah.
نقدر نحكي
You're
ما اقدر
لاخن لاخن ألمانية لاخن
لاخن.
لاخن
فرح هاي العيد
It is very trivial that the closure of Q is a subset of R. For any set, okay, it is very trivial that this closure is a subset of X because all of these are subset of X, okay? The closure is a subset of X. In this example, the closure of Q is a subset of R. So we must prove this relation. R is a subset of Q bar, okay? For this, if X belongs to real line, then for any neighborhood of X, we know that there exists an open set such as this, such that X belongs to this open set, and this open set be a subset of N, okay? And this shows that the intersection of N and Q is non-empty. you know that in any open interval we have infinitely many irrational numbers. Do you know or not? In any
انت شادي انت شادي
المشاكل ما مطي تربية.
لهم
المشاكل شو تعرف
المفروض تطلع على
كيف
الزيرو.
تنفع؟
in any interval
الزيرو
we have infinitely number of irrational numbers. Irrational numbers.
النسبية بين هناك أسعار الزيرو.
Irrational
يصير
number.
مقام صفر.
نشرها.
Irrational. Uh, rational number, okay? Rational number. Not, this is irrational, okay?
تخلص بقى تخلص.
Rational number. Thank you. So that X must be belong to the closure of Q. So that any element of real number belong to the closure of Q. So that we have this, okay? So that these two must be equal. And this is a very, very important example of dense subset. Q is dense in R with Euclidean topology. Euclidean topology.
سهل.
And this is the definition of base. Any topology have a base, okay? Base.
دكتور تلفت خاصة ثاني.
خاصة شو دي؟ Okay?
براي فردا.
We can continue tomorrow, okay?
Yes.
هذا خاصة شو دي؟
لا عادي دكتور عديد.
خاصة شو دي؟
لا لا.
ها؟ فقط خاصة شو دي؟
لا.
نفس
هي چند دقیقه
Okay.
اوکی چند دقیقه let X and tau be a topological space and beta be a subset of tau. Beta is the base for tau if and only if we have this relation. For any U in tau, there exists a family in beta such that U be a union of A alpha. Then we say that beta is the base for this topology. And also this is the definition of subbase. And this is an example, okay? This is the base for topology in R. This is the base for topology in R2. This is the base for topology in Rn, in Euclidean topology. Euclidean topology. Base of topology. This is the definition of Hausdorff. Your base is in this book, okay? Definition of base, definition of sub-base, okay? And other definition. Definition of Hausdorff space. A topological space is called Hausdorff when these 6 points can be separated by open sets. In symbols, if X and Y belong to X and X not equal to Y, okay? There exist two open sets such that X belong to U, Y belong to V, and U and V be disjoint set. I write this for you. For any X and Y in X, if X not equal to Y, there exists two open sets with these three properties. X belong to U, Y belong to V, and this intersection be equal to empty set, okay? We have two open sets such as U and V, such that X belong to U, Y belong to V, and these two open sets are disjoint. For example, R is a Hausdorff space. And this is a definition of continuous function. Let x and tau x and y and tau y be topological spaces, and f from x to y be a function. We call f continuous at x0 if the following holds for any neighborhood of f of x0. The inverse image of n be a neighborhood of x0. This is the definition of continuity and one point, okay? One point. This is continuity in whole of x. In whole of x. Whole, okay? F from x to y is continuous in whole of x. If and only if the inverse image of U is open for all open set, the inverse image of F is closed for any closed set. These three statements are equal. Okay. And the composition of continuous function are continuous, okay? Composition. We have three
تركيب.
Turkey, ahsan. And in Arabic, what is composition? Turkey. The composition of continuous function is continuous.
پنجم دبیرستان.
So in
بله.
Iraq. Okay.
لا اريدك تساله
Proposition.
امتحانات كيمياء وتطلع النتائج.
The following are equivalent. F from x to y is continuous.
شلون اسال؟
For any open set, open subset of y, the inverse image of u must be open subset of x, okay? Equivalently, if u be an open subset of y, the inverse image of u be an open subset of x. If f be a subset of y and is a closed set, the inverse image of f must be closed. This equal to this. If the complement of f is open, the complement of this must be open, because this complement is open if and only if this set be closed. Yes, guys. بالا بزن ببین اگه هستن اونا معلوم تموش کنم بهتره بدم. اگه هستن اونا بهتره بدم.
صادقنا عليهم صفحة ديب
یه صفحه؟
سه تا صفحه.
ضعفها والله إنه وقت من هيئته مدرس ويا شكل إيه
اوکی
جدیده این درسته؟
اوکی yes
فقط مال شما.
this is only for me.
اطفال نه
اوکی
بچه ها نه.
اوه بچه ها
بله همه دارن مرد.
شواتنا لما اطفال نخلص من هاي السالفه كلها. والله شواتنا
بله
دوستان
دوستان من میگم مرتضی قومی.
لا دكتور لا
نخلص من الحكي ونخلص من
ما تعبان لا دكتور
این
شفتی
خسته شدم تعبان.
من ناخست
نخست
من همه میرم بیرون.
نه
فقط عبدالرحمن
فقط ما دكتور مشكلة ليس فقط ما
فقط نه منم ازم ببینم یه جلسه ای شاید
او عندك شغل.
انت مو قلت تعبان؟
دكتور بعد الامتحان النتائج كم يوم تطلع؟ مرتبطة اليوم.
Maybe after 1 or 2 days because
يوم لا يوم.
شنو هذا؟
because شو
يعني تفتهم عربي طلع. عربي تفتهم.
شو؟
عربي نيجي ما هو بلدي.
عربي مي فهمه
يقول افتين بس ما اقدر اجاوب.
زين جاوب.
سيدي
كله خي يتعلم تفيده.
اوكي بس اخذنا منها صوره جماعيه بالامر عليه بس تكون حلوه.
ايام ضحك خاطب مره من عندك صور
بس ست اذا ما تحبين
ست
الصورة
بس.
عادي.
وين راح اوديها؟ دكتور بخشي فقط عكس
عايش
جماعيه.
بالنظام
تعال لا تعال صفي غير الشرك. قصة كل الشرك.
استاذ محمد دخل
لا، ما ياخذ.
دخل
لا،
على
لا،
ست شالك انت ياخذ معه مالك
ما ادري غير انت تريد ما تاخذ شو تسوي لك؟
لا لا استنى خلينا نبيع. شلون الجهال الحين؟ كيف الجهال
بس جاتة ما تصير فيه حتى تطلع.
دكتور خير ممنون ها.
اوكي
شرمندان مزاول شو
نعمل ان نستمر بعد اوكي
ان شاء الله
ناخذ تحليل هرمون هارمونيك اند اوبريتور
اوبريتور
بس فردا دیگه دوشنبه میشه امتحان چی؟
امتحان اوپريتور
اوپراتور سه شنبه میشه هارمونی چهارشنبه یعنی سه شنبه تعطیل چهارشنبه امتحان خیلی خوب دکتر خیلی ممنون
ثانك يو
شرمنده ها ان شاء الله خداحافظ
خدا
فهمت كسر